All right, so for foreseeable future, I'm pretty much gonna record this entire unit, which is gonna be on electric current and magnetism. Right, so all these lessons are gonna be posted online with the relevant worksheets. Worksheets. Now, this next part of the unit, well, last unit we learned about electrostatics, right? And the static part means basically the electrons weren't flowing, right? The electrons weren't moving. Well, I mean, I guess they were, but we learned more about them as static entities, right? Static charges. And we weren't really concerned about how electrons moved. But this unit, we're going to talk about electric current and actual electricity, right? What is actually electricity, okay? So as you can see in these two gifs here, you'll see that there's electric current flowing through. This lightning, this electricity is the flow of electrons. So if you haven't realized it yet, if you haven't picked up on it, electricity is basically the flow of electrons. There's nothing else to it. It's just the flow of electrons. And we're going to call that electric current, all right? And again, in this GIF, you see how electric current flows through a wire. So that uh, in the middle right there, that conductor, you'll see conductor, and conductor is any metal. Any metal is considered a conductor. And so you see these electrons flowing through a wire. We can call it a wire, like one of those power lines you see up on the streets. So that thing in the middle is a wire, and so electrons are flowing through this metal wire. Well, what's causing them to flow through this wire? Well, you'll see on the left-hand side, you see something called higher potential, right? When it says higher potential, we just mean the higher voltage. Right? Let's say there are tons of electrons on the left-hand side. What do they all want to do? If there are so many electrons on the left-hand side, all the electrons want to get as far away from each other as possible. They want their social distancing, right? And so on the right-hand side, you see lower potential. There's less of a voltage there. There are less electrons on the right-hand side. So naturally, the the crowded area, the electrons from the crowded left-hand side, they will want to eventually move to the right-hand side where there's less electrons, right? There's more repulsion between these electrons on the left-hand side, and there's a less repulsion on the right-hand side. And so naturally, they're going to want to move from the higher potential, the higher voltage, to the lower potential, the lower voltage, right? And how do we measure electric current? So there's a formula for that right here on your reference table. Where is your reference table? On your reference table, it's on the electricity page, right? This I is delta Q over T. So I is delta Q over T. And I is electric current. I is electric current. Right? Uh, that's how much electrons are flowing through your wire at any given moment. And delta Q is your total charge, or your total charge flowing through a wire, through a wire. And your time is the time it takes for that charge to flow through. All right, time it takes for that charge to flow through. And you can pause it here if you want to take a look at it more clear because I'm about to erase it in 5, 4, 3, 2, 1. So now let's actually get to solving these problems, right, involving electric current. So your total charge of 100 coulombs, so your charge is 100 coulombs. All right, pass a fixed point in the circuit every 500 seconds, so 500 seconds. So what is the current at this point in the circuit? So I is your electric current. All right, I is your electric current. So we know that I is delta Q over t. So delta Q is 100 and t is 500. And so you're going to get a number of 0.2 amperes, okay? So that's how you measure current, amperes, and we can abbreviate that as A. And usually, sometimes we like saying amps, right? Amps, amperes, A. They all mean the same thing. They're current. This is how you measure electric current. And so the answer is going to be uh, A. I'll do one more with you guys. One more with you guys. Draws a total charge that passes through. Now, let's do number two. In number two, you haven't. There's a unit you haven't seen before, and a word you haven't seen before. 2700 ohm resistor, right? 2700 ohm resistor. You can just ignore that for now. All right, if you're on this page, the only thing you really care about is delta Q over T, right? So you're in this problem, it says an electric circuit draws a current, right? So you know your current is 2.4 milliamps, and we know that we need to convert it to amperes, and so milli, if you look at your reference table, where is your reference table? Milli, all the way at the top. Milli, 1 m is 10 to the negative 3, right? So 1 ampere is 10 to the negative 3 milliamps, right? Which means that if we want to get this unit into amperes, what we're going to have to do is multiply by 10 to the negative 3. Okay, so this would be 2.4 times 10 to the negative 3 amperes. Easy, simple as that. If 1 ampere is 10 to the negative 3, multiply this number by 10 to the negative 3. Now, and it says the total charge, you want to find out what the charge is, and you know your time. So the problem gives you your time. Now, you're going to set up your equation. Right here, I is 2.4 times 10 to the negative 3, delta Q over 15 times 15 times 15. So you're going to get 2.4, 30 divided by 10, 1.5 times 4 is 6. So 36 times 10 to the negative 3 gives you your delta Q. And that's actually 2.6 times 10 to the negative 2 coulombs, right? Coulombs. So is that an answer choice? Yes, it is. It's choice number B. All these other questions are pretty much the same thing. The only one I would be really careful for is I mean for 4 and 5, the problem, so for 4 and 5 they don't give you the charge. What they give you is they say 2.5 times 10 to the 19 electrons. So to first solve this problem, you have to convert this number into a charge. And you know that one elementary charge is negative 1.6 times 10 to the negative 19 coulombs. So what you're going to have to do is you're going to have to multiply the amount of electrons by this charge, right? And so you're going to get, what are you going to get? Divided by 10. Uh, you're gonna get something. You're gonna get numbers, right? Because it's 2.5 times 1.6, because these two cancel out. So you're gonna get some number uh for your charge, and you do the same exact thing for number 5. So number 5 gives you another value for the amount of electrons. Number 6, you just have to convert the time into the seconds, right? Because if you're given a time of 2 minutes, what's that in seconds? And so that's actually it. That's fine.